Okay, boys and girls, welcome to our last video lesson in Chapter 12. We're now going to discuss and look at the ratios of lengths, areas, and volumes. Okay, here we go. Okay, let's talk about similar solids or similar shapes in 3D. For example, these two prisms, these two triangular prisms, look like they are similar. They have the exact same shape and size. These two triangular prisms look like they're similar. They have the exact same shape and size. If two solids are similar, their scale factor, their linear measurements, that ratio, in this case it would be 2 to 3. This ratio, if I square that ratio, I get the ratio of their areas, and we know that from chapter 11. Okay, and now the new stuff, if I cube the scale factor, 2 to 3 cubed is going to be 8 to 27. So let me show you how that works. Okay, so the problem that we just did, if we remember now, if I take my scale factor, the ratio of the linear measures, and I square it, I get the ratio of their areas. If I take my linear measures and I cube them, I get the ratio of their volume. So actually, let's do a different number right now. What if the scale factor of two shapes was 3 to 4? If I square 3 to 4, I'm going to get the ratio of their areas. So that would be 3 squared, which is 9. 4 squared is 16. So that would be the ratio of their areas. If I take the same scale factor, 3 to 4, and if I cube that, I'm going to get the ratio of their volumes. So 3 cubed is 27, and 4 cubed is 64. So that's how we would do those. So let's do a couple. Okay, determine whether each pair of solids is similar, congruent, or neither. If the solids are similar, state the scale factor. So let's look at the two triangles. This has a height of 14 and a radius of 4. Did I say two triangles? I meant cones. This cone has a height of 14 and a radius of 4. This cone has a height of 10.5 and a radius of 3. So what we got to ask ourselves is 14 to 10.5 equal to 4 to 3? Well, yes, 14 to 10.5 is equal to 4 to 3. So 4 to 3 is equal to 4 to 3. These are similar, and that is the scale factor, 4 to 3. In this second one right here, this is a square pyramid. This is a triangular pyramid. Well, guess what? No, they're not sim. We're done. Okay, two similar prisms have surface areas of 98 square centimeters and 18 square centimeters. What's the ratio of their heights? And the heights are linear, so we're actually going to go from area to a linear. So we're going to write the ratio of their areas. 98 is to 18. Just to make my life easier, I'm going to simp that. I'm going to divide both of those by 2, right? So I get 49 is to 9. Well, that's the ratio of their areas. How do I take that and make that the ratio of their linear measurements? I'm going to square root both top and bottom. So I'll write that in purple. Square root 49, square root of 9. Square root of 49 is 7. The square root of 9 is 3. So the ratio of their lengths is 7 to 3, so that would include the ratio of their heights, because the height is a linear measurement. Moving on to this one, a regulation volleyball has a circumference of about 666 centimeters. The ratio of the surface area of the ball to the surface area of the children's ball is approximately 1.6 to 1. What is the circumference of the children's ball? So let's just think about the surface area. The ratio of the surface areas of the two balls is 1.6 to 1. So this is an area measurement. It's 1.6 to 1. Okay, so those were the ratios of their areas. I want to compare the circumferences of the two balls. Well, the circumference is a linear measurement, so I'm actually going to take the square root of both top and bottom to get my linear measurement. The square root of 1.6 is approximately 1.26. I did use my calc for that, and the square root of 1, of course, is 1. So the ratio of their linear measurements is 1.26 to 1. I now know that the circumference of the larger ball is 66. The circumference of the smaller ball is what I'm looking for. I'm going to use my calculator and cross multiply right now. And as I do that, I get an answer of 52 centimeters when I round. Alrighty, let's do a couple more. Two similar cylinders have radii of 15 inches and 6 inches. What's the ratio of the surface area of the small to the large? So again, we have two similar cylinders where the radii are in the ratio of 6 to 15. Well, these are the radii, so these are linear measurements. I'm going to reduce my 6 to 15. I'm going to divide both by 3 right now and get 2 to 5. So the ratio of their linear measurements is 2 to 5. In order to find and convert that to my area measurements, because that's what I'm looking for, the ratio of the surface areas, I'm simply going to square the scale measurement. So it looks like 2 squared is 4. 5 squared is 25. So the ratio of their surface areas is 4 to 25. 1. Here we go. A company sells two different sizes of exercise balls. The ratio of the diameters is 15 to 11. 15 to 11 is a linear measurement. The diameter of the smaller ball is 55 centimeters. What's the volume of the larger ball? I am not going to do this one for you. I've given you a good start here. Remember, we're looking for the volume of the larger ball. First 10 people to email me with an answer. The correct answer will get a bonus point on your next test or quiz. That's it, folks. Have a great day, and we'll see you soon.